just a quick comment. We're still going to move points, but sometimes it helps to see what the whole thing is going to do. And I'm going to show you with stretches and shrinks how this works. These are stretches. You get this. If you plotted y equal x squared, it's going to be 0, 1, 2, 4, and up. 0, 1, 2, 4, and up. Did you sketch that in your iPad? I'm going to show you a little technique that I think is brilliant. It's absolutely brilliant. So you're going to take from 0, 0, go to, just make a box up here to 2, 4. Now when we go to y equal 2x squared, what we're saying here, is this inside or outside the function? Outside? So what we're saying here is we're going to affect, if it's outside, it affects the y. All right? So we're not going to change the x with this box. We're only going to change the y. So I'm going to make a box that at 0, 0 still goes out to 2, but we're going to double it up to 8. So this corner here, which was at 2, 4, now is going to be at 2, 8. And then when I graph it to that corner, what does the graph do? How would you describe it? It shrunk widthwise. It stretched lengthwise. The x doesn't change, okay, but the y did. And you can kind of see 2 is the x squared and the x squared don't change. Let's do that with this one here. So we'll take the 1, 1, 2, 4 going up. 1, 1, 2, 4 going up. And then we make our little box. Two, 4. And this time it says that instead of the y going double that, what is it saying the y needs to do for this guy? What is it saying? Shrink. It's saying the x's don't change, but the y's are going to be 1/3 as big. So it's going to be about to here. And so now when I draw that purple, it goes like this. Then we mirror it. Now what did it do? It kind of, we'd call it shrink vertically. But you can really see that, can't you? With that. Isn't that easy? That's easy. Now, the other method is using the boxes and shrink. What stays the same here with y equal to, let's say we have parenthesis 3x squared, or y is equal to parenthesis 1/2 x squared. What happens there is you set this equal, and you're going to see something else happen. What will happen to the box is the y will stay the same, but this is going to be 1/3, and this is going to be 1/2, which we'll look at right. So vertical scaling, you can see that as phase greater than 1, it's going to get stretched up. If it's between 0 and 1, it's going to get scrunched. Negative, we'll flip it over. So now we're going to do, I think I want to do the 1/2. We're going to do the inside. So this is the inside function. M stands for Mankato. No? What would be better? Oh, Minnesota, there you go. Or Minnetonka, either one. So we're going to take these points and we're going to shift them. So for this thing here, we're going to take the point 0, 0. And so what happens to the x? What happens to the x here? By the way, I think what happened here is I bet, clone. Let's do the ungroup. There we go. Now we're talking. This is supposed to be moved over to here. Oh, maybe not. Ugh. Let's do it this way. All right, so we're going to take this point, we're going to take the x, and we're going to turn it into 1/2 x. So what we'll do is 1/2 x equals 0. So what's x going to be? 0. That won't change. Okay, so then the next thing we're going to do is what happens to the y of 1/2 x? Does that change? Does the y change? Nope, so that'll still be 0. So the point is going to be 0, 0. So this one won't change for this one. But watch what happens with the point 1, 4. Now we have a 1 for x. 1/2 x equals 1. So now you're going to have x is equal to what? 1/2 x equal 1. What's x equal to? Come on, come on, come on. Just say it. Solve for x. X is equal to 2. There you go. So there will be 2. So this point is going to be 2, and let's see. So x was equal to 1, and then the y stays the same at that. So it's going to be moved in here. So it's going to be 2. Oops. Wait a minute here. I got a little misfire here. So x started out at 2, then it's 1. So I'm doing this point, and the y is still 0. So we'll stick with 0. So this point moves to here. Let's do the 4 next. Okay, so we have 4, and when we put 1/2 x equal to 4, then what will happen is x is going to be what? 8. So this is going to be 8, and then the y is still the same, 0. So this is going to be moved out to I don't know if that's going the way I want it to. So we had 1. Okay, we had 0, 0. Then we have 4 goes to 8. And this 2, oh, I see what I did. This was meant to be 4. This was meant to be 2 goes to 4. So this is going to be 2, and this is 4. This is 4, 0. Sorry about that. And then if we shift the other ones up here, this goes here, and this one goes here. What's the effect of connecting those? Minnesota, Minnetonka, Mankato. What essentially happened to this whole thing? Stretched, right? So the idea here is that when you have the 1/2, it's the opposite. It stretches when it's in the function. It shrinks when it's outside the function. But you can just prove that with the points. And I didn't do a very good job of explaining that. Then the last thing we want to do is how do you put these functions in a row? How do you get these to go one after another? Find and simplify the formula for the graph. Check using your calculator. So vertical shift up to, what happens to x squared if it goes vertical shift up to, what do? It'll be x squared, and then what do? Up to will just be +2, right? So we did that. Now we're going to keep going. Reflect across the x-axis. That means what we did is we moved it up, and now we're going to reflect it across the x-axis. Now what is going to happen to this equation that was y equal to x squared plus 2 if we reflect this over the x-axis? It's going to go down here, right? So do we just do negative x squared plus 2? What that'll do is negative x squared plus 2. You're saying that this is it, but it's not. What happens is when we reflect it, you got to reflect both of them. You got to reflect both the x squared and the 2. So what'll happen is you're going to flip it, and then you're going to go down 2 more. And so this is where you get negative x squared minus 2. Does this look more like the flip over of this one? Yeah. So one more time. When you take the opposite and flip it, or minus g of x is what they said, don't forget to take the opposite of both. So this is going to turn into y equal negative x squared minus 2. Yay! Okay, and then it says a horizontal shift to the right 1. Well, that's no problem. Just take the x and move it minus 1. So that's fine. That's just going to be y equal to negative x minus 1 squared minus 2. And you can expand that. That's what they did there. And then the last thing is a horizontal stretch by a factor of 2. So then we take this whole thing and multiply it by what? If it's vertical stretch. Remember the boxes? If it's a y stretch vertical, then what happens is you just multiply the whole thing by 2. And I think what they did is they just took this and multiplied by 2. Oh, horizontal, I'm sorry. Horizontal stretch is the opposite. Yep. So you're going to, when you do it the opposite, that was vertical. If we're doing a horizontal, you're going to do it this way. So we're going to put in a 1/2 x in for x, and then that's where that comes out. So what you're doing with the equations is you're plugging these in, but watch your order. Hi. Right? So let's go to number 54. Let's see what you can do with 54, 55 right now. I'm going to do a couple of these here. Reflect across the x-axis. So that's going to be, yep, it's going to flip it on the outside. And then it's going to shift up 1. So you're going to go up 1. So it's the opposite of the square root of x, up 1. We're recording here, so. Yep, and so you try these 3 quick. And then if you finish them, do the previous slide, and then you should be all set. And that's all we'll do for the recording today.